Hello, welcome to chapter 9. This chapter we're going to talk about how to presenting categorical data graphically. So we're going to learn two really useful statistical tool, which is histogram and plus box. So here's an example. What is a frequency? Let's talk about the definition. What is frequency table? A frequency table is a table with two columns. One column lists the category and another column is the frequency with where the item category occurred. So how many items that fit in each category? So for example, an insurance company determined a vehicle insurance premium based on known risk factor. If a person is considered high risk, their premium will be higher. One potential factor is the color of the car. This is really interesting. So maybe when you're buying a car, you can take into the car into consideration, because maybe if you get some certain color of the car, you will get a higher premium. So let's go back. The insurance company believes that people with some colored cars are more likely to get in accidents. To research this, they examine police reports for recent total loss collisions. The data is summarized in the frequency table here. Blue, which is that is the category of color, and then here is the frequencies. So for blue car, there were 25 cars was reported in collision. Green car, there were 52, red is 41, white is 36, black is 39, and gray is 23. So this is the frequency table. Okay, so what can we do with the frequency table? Well, sometimes we need an even more intuitive way to display the data. This is where the charts and graph comes in. There are many ways of displaying the data graphically, but we will concentrate on one very useful type of graph called bar graph. In this section, we were going to work on the bar graph that display categorical data. The next session will devote to the graph that display quantitative data. So for bar graph, so what is a bar graph? A bar graph is a graph that displayed a car for each category with the length of each part indicated the frequencies of the category. Note, a bar graph is only used to display categorical data. To construct a bar graph, we need to draw a vertical axis and the horizontal axis. So the vertical axis direction will have a scale and measure the frequencies of each category. And the horizontal axis has no scale in this instance, but only the names of each category. The construction of bar chart is mostly easily described by the use of examples. So here's one, like the previous example. Using our car data from above, note the highest frequency is 52. So which car occurs 52 is the green one, right? And then our vertical axis needs to go from 0 to 52. So we might just as well use 0 to 55. That's the range for our vertical axis, so that we can push a hash mark every 5 units. So of course you can go as far as 0 to 100. You can go as high as to 60, 70, go to 100. But you need to give them the fact that your data, the frequency, the highest frequency is 52. And the lowest one is what? 25. So you need to know the range so that you don't go crazy about your graph. You can go as high as like a 1000, but it just made no sense that you have a small barcode. So you want to optimize it. So that's why we pick 55. But I've seen some student not some student. Maybe you will think, okay, do I have to mark every 5 units? Not necessary. You can mark every 10 units. So I would like to show you an example how to make a bar graph. with our graphical tool, you can either use Excel, Google Sheet, or Desmos. For today's example, I am going to use a Google Sheet. So here is the example. I already typed in all the data. So what you would do is you highlight the data that you wanted, including the title, and then choose, oh, hold on. Yeah. And then you would see there's two bar on the top. You need to choose insert. After you highlight it, insert, there's a chart. And then on the chart, you can choose what chart do you want. So automatically, they will give you this bar chart. So now, as you can see on our vertical axis, it's no longer every 5 units. In this case, they give you every 20 units, which is also fine, no problem. But you need to keep it consistency. You can do 20, 40, and then here is 50. No, each lens, they should have the same unit. So in this case, it's marked every 20. So you can play around on the right side of the setup. You can set up about you can also choose to show customize and then choose to show the neighbors, which is in here. Were you able to see that? Chain 9, you will see the chain 9 and the data labels. You can just play around and then they will count the numbers for you. So this is how you use the Google Sheet to make it. Of course, you can use other to just explore it. And there's a decimal and GeoGebra, and you can also use Google Excel, and also I believe there's lots of online tool that is free that you can use to make the graphical bar, or you can also draw it by yourself. Okay, so now let's continue. Okay, so next is bar graph. So a bar graph, oh, we just talked about what I was talking about. So the next one would be parental chart. So parental chart is the similar idea, is a subcategory of bar graph. So parental chart is a bar graph order from the highest to the lowest frequencies. So that means you will order, since our green occurs the most, which is 15.2, so we arrange the highest frequency and then to the lowest. And then the next category will be red, and then black, and then white car. So it seems gray car is statistically is the safest one, has less total collision damage reported. So this is parental chart. So now take a look. So in a survey, adults were asked whether they personally worried about a variety of environmental concerns. The number out of 1,012 surveyed, so there were totally 1,012 adults participate in that survey, who indicated that they worried a great deal about some selected concerns are summarized below. One is pollution of drinking water, which there are 597 people are concerned about that. And then contamination of soil and water by toxic waste. There are 526 people worried about that. And then another 455 people worried about air pollution. And only 350 people out of 1,012 people worried about global warming. So the data could be shown graphically in a bar graph. So let's try to make a bar graph on our Excel sheet. Let me type it in. I'm going to pause and you can also do it by yourself. Okay, I just done typing the data, and what we can do is we highlighted the data and choose insert on top of the toolbar and choose chart. and they will give you a bar chart. We'll talk about that later, but today we're not going to use, right now we're not going to use pie chart. That would be our next topic. So in the setup, you can choose bar chart or other histogram. So we can use frequencies versus issue. So here is the bar that you will be able to see it. Again, you can play around the customize and the setup. You can choose to set up a switch the row and the column, and then they will change the color that you would like. And when you customize it, you can also choose have them to set the data labels for you. Either way, so it's pretty fun. I really like play around the datas. Okay, so another way to do it on your homework, what you can do is you can draw it by yourself. So now let's take a look. So the maximum value is 567, so you can go as high as 600. And then starting from 300, so you can do every 100 as the unit. You can draw it by yourself on your homework on during your quizzes. That's also fine. And then you label it, your data on the axis, the pollution of drinking water. I'm going to pause it and do it by yourself. Okay, I just done label all the horizontal axis. So for vertical axis, we need to choose how frequent we want to mark it. Since the range is from 0 to 600, we can mark every 100. I don't have a ruler now. When you're doing your homework, try to use a ruler. Make sure that each of these, the width, should be equal. Okay, so when it comes to air pollution, we have 597. So we can draw our first bar, which is here. And then you can label the number, the frequencies on top. And then for the contamination, we have 500, which is a little bit above 500. 526. And then for third one, air pollution is 455. So that means it's in between 500 and 400. For the last one is the concern about global warming, which is 354. So that means it's between 300 and 400. So approximately here. But you definitely can do a better job than me. So this is kind of just scratch. Okay, so the next one I want to talk about is pie chart. So a pie chart is a circle with a wedge cut of the various size marked out like slices, pie, or pizza. The relative size of the wedges corresponding to the relative frequencies of the category. Usually they present it in a percentage way. So for example, the vehicle color involved in the total loss of the collision. They even changed the color, but they didn't label how much it is. So we can label it here. So usually this is by percentage. So for example, for the car, we have the blue car is 52. And then the red car is 41. The black car is 39. White is 36. Blue is 26. Gray is 23. And the total number of cars is 216. So basically this is out of 216. And then you calculate the percentage. Again, we can use the Google Sheet to do it for us. Oops. So in Google Sheet, we can have, hold on. So in this Google Sheet, instead of highlighting, let me move this on the side. Instead of highlighting, we can highlight in this data and do it again, or you can just edit this one, which is the editors, is on the right side. And then you can choose, hey, setup. Now the setup is column chart, which is our bar chart. They're also called column chart. You can choose, there's so many charts that you can choose. You can choose a pie chart. With this pie chart, oh, this is the contamination, not the car. Haha. I choose the wrong one. I should do this one. This is the car. Let me zoom in a little bit. So in here, at setup, the chart type, you can choose the bar chart. So now, as you can see, the blue takes up about 11.6% and green is 24.1%. Of course, you can also change the color of the pie chart to the corresponding color that you want. So again, just play around with it by yourself, and you will find that is really fun. Okay. So another gram is called pictogram. So a pictogram is a statistical graph. Oh, I forgot to share it. So a pictogram is a statistical graph in which the size of the picture is intended to represent the frequencies of the size and the value being represented. For example, in this example, so a labor union might produce the graph to the right to show the differences between the average manager's salary than the average co-worker's salary. So this is quite straightforward, right? The manager's salary is bigger because by the graph, and then the workers are smaller. So when you look at the picture, it would be reasonable to guess that the manager's salary are 4 times as large as the worker's salary. So the area of the bags looks about 4 times as larger. However, the manager's salary are in fact only twice as large as the worker's salary, which were reflected in the picture by making the manager bag twice as tall. So this is quite interesting. Okay, so here's an example. So a poll was taken asking people if they agree with the position of 4 candidacy for the county officer. Describe the pie chart presented a grid representation of the data and explain why. So now take a look. We have 4 candidates. McKee, Brown, Jones, and Nian. And then describe, is that it represent a good, I would say this is really good representation of the data because it looks good, right? Because they tell you how many percentage were there. Like Nia got 14.2% and then McNee got 13.5%, Brown got 52%, and John got 60%, 64% of support. That looks really reasonable. However, there's a catch. For the bar chart, the total of these percentage should equal to 100%. But this one is already exceeded 100%. So I would say this bar chart doesn't present a really good representation of the data. They must do something calculating wrong. Because when you look at this one, so I should use blue because there's not blue, green. Because look, if I cut this evenly into 4 pieces, we know that each piece should be 25%, right? But look at this candidate. It's definitely less than 25%, but somehow it says 14.2%. So this is not a really good representation of the data. Okay, so this is our chapter 9.1. It's really interesting. I love playing around the data. So let me know if you have other questions.